Next, we want to talk about integration of even and odd functions. So occasionally, you can simplify the evaluation of a definite integral over an interval that is symmetric about the y-axis or about the origin by recognizing the integrand to be an even or an odd function. Okay, so let f be integrable on the closed interval negative a to a. So it's got to be the same distance away from 0 here. Now if f is an even function, then the integral from negative a to a of f of x dx is going to be 2 times the integral from 0 to a of f of x dx. So let's see what we're talking about here. This would be an example of an even function. And notice if we go from negative 1 to 1 that it's symmetrical about the y-axis. So basically what we're saying is if you can find this integral from 0 to 1 and you double it, you're going to get the entire integral. Now if f is an odd function, then the definite integral from negative a to a of f of x dx equals 0. So here is our odd function. And notice that it's symmetrical about the origin, so it has rotational symmetry. And what we see, if we go from negative 1 to 1, we can split this into two integrals. And if we go from 0 to 1, we get an integral that is positive. And if we go from negative 1 to 0, because this is below the x-axis, this integral is negative. And since they're the same size, when you add these two together, we get 0, or they counter each other out. Now again, to determine whether a function's even, remember, just substitute x with negative x, and then you're still going to get f of x. So what I mean by that is if you plug in negative 1, f of negative 1, you're going to get the same thing as f of 1. For an odd function, if you plug in negative x, you're going to get negative f of x. So what I'm saying here is if you plug in negative 1, you're going to get the opposite of if you plugged in positive 1. Okay, now some other things that we just want to look at here that can definitely help us out is if you have the sign of a negative x, that equals negative sine x. If you have cosine of negative x, that is going to equal cosine of x. If you have tangent of negative x, that's going to be negative tangent of x. If you have cosecant negative x, you're going to get negative cosecant x. If you have secant of negative x, that's going to give you secant x. And if you have cotangent of negative x, that's going to give you negative cotangent x. Now why did we do that? Well, notice we were trying to determine whether these are even or odd. So if we plug in a negative x and we get out the same positive function, then that's going to be even. If we plug in the negative x and then we get out the opposite of the positive function, then that's going to be odd. So here we plugged in negative and it spit out negative sign. So this one is an odd function. Here, cosine of negative, it spit out the positive cosine. So this is an even function. Okay, what do you think tangent is? Well, we plug in the negative x and we get a negative out. That's going to be odd. Cosecant, this one's also going to be odd. Secant, this one's going to be even because we plug in a negative and we get out a positive secant. And then cotangent, this one is also going to be odd. So what this can do is help us determine some integrals involving our trig functions. Okay, so we're asked to evaluate this definite integral from negative pi over 2 to pi over 2. So we can see that we have the positive and negative here of our limits of integration. So if we know if this is an odd or even function, then we know how to integrate this a little bit more easily. So let's just take a look at this function right here to determine if it is odd or even. So what we're going to do is go ahead and let x be negative. Okay, so we're going to get sine cubed of negative x cosine negative x plus sine of negative x cosine negative x. So that's your first thing that you got to do, is substitute negative x in to your function. Okay, and let's go ahead and determine what this is here. So if we cube the sine of negative x, remember that if we have sine cubed, we're basically saying sine of negative x cubed, so cubed will take the same sign as we had before. So sine of negative x goes to negative sine x, so this becomes negative sine cubed x. Cosine of negative x becomes positive cosine x. So we're just going to leave it here as cosine x. Here, sine of negative x turns into negative sine x, and then cosine negative x turns into positive cosine x. So here is our function now, and what we are going to do is factor out the negative here. So we're going to be left with sine cubed x cosine x, and then plus sine x cosine x. And what this is negative f of x. So you can see that this function right here and then the function inside here are exactly the same, and the only thing that changed was the negative. So it becomes negative f of x, meaning this is we know that f of negative x equals the negative f of x, making this an odd function. Okay, so we're going to take these two pieces of information that we're going from negative pi over 2 to pi over 2, and this is an odd function, so therefore this is going to equal 0. So sometimes that will work out. Go ahead and try the next one on your own. Okay, first see if the odd function trick can work, and then determine whether it's odd or not. So go ahead and give this a try on your own. Pause the video, come on back when you're done to check your work. Alright, welcome back. So the first thing you need to notice is that our limits of integration go from the negative pi over 4 to positive pi over 4. So it benefits us to see if this is an odd or even function here. So we're going to substitute negative theta into our function. So we get tan of negative theta, secant negative theta. And we know tan of negative theta is just going to be negative tan. Okay, and then secant of negative theta is going to be just secant. So we get negative tan theta, secant theta, which is negative f of theta. And so because f of negative theta equals negative f of theta, this is an odd function, making this integral equal to 0. Alright, we'll just try a couple more examples here, just using x's. So here, notice the negative 1 to 1. So we need to determine, is this odd or even? So we're going to plug negative x into our function. So we have negative x times negative x squared minus 1. And so it's negative x times, well, negative squared becomes positive, so x squared minus 1. And you can see that this is the negative f of x. Okay, so that does make this an odd function. Therefore, this is going to equal 0. Alright, let's try the next one. Negative 3 to 3. So we need to check, is it odd or even? So let's find f of negative x. So now we're going to get negative x squared times negative x squared minus 2. So here we get x squared times x squared minus 2. And notice that this just equals f of x. It equals our original function. So when f of negative x equals f of x, this becomes an even function. Okay, so because it's even, we can rewrite this as 2 times the integral from 0 to 3. Because it was symmetrical, so we can just go from 0 to 3 of x squared times x squared minus 2 dx. Now looking at this, we don't have a u substitution, so let's just go ahead and distribute the x squared here. So we're going to get x to the 4th minus 2x squared dx. And so this is going to be 2x to the 5th over 5 minus 2x cubed over 3. And this is going to be evaluated from 0 to 3. Okay, so it makes it a little bit easier having that 0 now, because if we substitute 0 in here, that becomes 0. So it's really just going to be 2 times 3 to the 5th over 5 minus 2 times 3 cubed over 3. And we're basically going to subtract 0 from that. And all in all, fraction-wise, this becomes 306 over 5, which is 61.2. Alright, so that's using our knowledge about even and odd functions to evaluate integrals from the same difference on either side of the y-axis.